Homework number 17 on DeltaMath. The first topic is on translations of a point. When you're asked to translate a point, you have to focus on whether you are moving the point up, down, left, or right, because these movements affect the coordinates differently. If you are moving left or right, that is math that is being done to the x-coordinate. If you are moving up or down, that is math that is being done to the y-coordinate. Sometimes you're adding, sometimes you're subtracting. If you're going up, you're adding. If you're going down, you're subtracting. Same is true with the x-coordinate. If you're going right, you're adding. If you're going left, you're subtracting. So let's take a look at what we're being asked to do. We're being asked to translate 4 units to the right. Well, when you move right or left, that's a change to the x-coordinate. Since we're moving right, we are going to add. So to our x-coordinate, we are going to add 4. That gives us a new x-coordinate of 7. The other direction we're asked to move is 1 unit up. And we're moving 1 unit up, we're adding to the y-coordinate. So we're going to add 1 to the y-coordinate. And that is our new point. So we type our new coordinates here in the boxes, and we submit our answer. Let's try another problem. Remember the movements. The x's, add or subtract if you are moving left or right, and the y values you add or subtract if you are moving up or down. Our first translation is 5 units to the left. That means that we are going to subtract 5 from the x value. Our next movement is 3 units up. We're going to add 3 to the y value. Our new point will be 1, 10. One last time. 4 units to the right. That means we are going to add 4 to our x-coordinate. 2 units up, we're going to add 2 to our y-coordinate. That gives us 13 and a 10. Let's go back to the next topic. Identify a translation using a guided sequence. So they are asking us to determine which translations would map, that means move, figure Y, which is the blue figure, onto figure Z, which is the green figure. So we're moving from blue to green. So if I pick a point anywhere on this blue figure, and I can identify where it is on the green figure, then that is my translation vertex. And that is what I'm going to try and find directions to. But I'm only allowed to move along the grid lines, not diagonally. So what I want to do is get from this purple dot to that purple dot by only moving up and down or left and right. Since the x-coordinate is first, let's try and find the movement for this coordinate. So we're going to move over 1, 2, 3 units to the left. So we moved 3 to the left. Then from there, 1, 2, 3, 4, 5 units up. And now I can select this from this option menu down here. A translation to the left, 5 units, and up, translation left 3 units, and translation up 5 units. So I'm going to erase my writing, and now we're going to click the try button. We'll watch the animation as it moves. That's it. Now you can submit your answer. Remember to read carefully which way you are transforming. So we are transforming here from figure B to figure C. That's the way that we're moving. So it looks like it's going to go to the right and it's going to go up. Just some basic observations. I already know that I'm going to move to the right and that I'm going to move up. So I can select these words immediately. Now don't forget you have to pick corresponding points. So you can only move a point that matches from the beginning shape to the ending shape. Bottom right corner, bottom right corner. And you can only move along the grid lines. So to the right, 1, 2, 3, 4, 5, and then up, 1, 2, 3, 4. Once you type those values in, you can try the animation. If it maps correctly, it will allow you to submit. Let's try the next section. Now you're going to translate the figure graphically yourself. Now that we're understanding the movements, we're going to click the points where the new shape should be. Translate the figure 3 units to the right and 1 unit up. That means I need to move all 3 of these points 3 units to the right and then 1 unit up. Every point. So take your cursor, choose a point to start with, and then move that point 3 units to the right, 1, 2, 3, and 1 unit up and click. So that's this point. Now I have to go to the next point. This one will be 1, 2, 3 units right, 1 unit up. And it will connect the line for you. Last point. 1, 2, 3 units right, 1 unit up, and now we're done. From each corner, you will move the directions you are instructed to move. 7 units right, 4 units down. From each vertex, and you should plot them in order, because it's going to connect the points that you plot. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. I started with this one. The next point I graph has to be something it already connects with, because it's going to immediately draw the line. So I'm going to go in a counterclockwise position. I'm going to go around this shape this way. So I'm going to move to this next point. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. You can move by counting boxes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Or you can move by changing the coordinates. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Last one has a point of -1, 4. So 7 to the right and 4 down. So this is going to give me a coordinate of 6, 0. So you can also, besides counting, you can just plot points like this. Once you're done, click Submit. When you finish, it will show you the vectors that translate the original image to the new image. You'll notice they're all the same size in length, and they're all the same distance from the old shape to the new shape. Let's take a look at the last 2 topics, which are review for you. The first one is to determine if a graph is a function. You may remember the definitions for functions as every input has only one output, or that it has to pass the vertical line test. So a vertical line test can very quickly tell you if an input has more than one output, because your vertical line would touch your graph in more than one place. You'll notice that I never touch my graph more than one point at a time. So this one is a function. This one here, if I try my vertical line test, I never touch the graph more than one time, so this one is also a function. Now watch this animation as the vertical line scans your graph. You can use your pencil or your finger as well. This one passes the vertical line test, but this one does not. I touch in this location and this location. Therefore, it is not a function because it does not pass the vertical line test. Let's take a look at the last topic, writing equations of lines. So in this task, you are asked to write the equation of the line in fully simplified slope-intercept form. This is slope-intercept form. We find this number first by locating a point on the y-axis known as the y-intercept. For us, it's a -7, so we will put a -7 in that position. This number is how you move from point to point along the grid lines known as the slope, or known as the change in y, delta y, over the change in x, delta x. So you're going to need to count some boxes here in order for you to find the change in y and the change in x. So we're going to go from -7 all the way up to -2. That is a difference of 5. Then we're going to change from 0 on the x number line to -4 on the x number line. That's how we move over. That's a -4. You have to put these two numbers in their correct placements. The change in y was 5, the change in x was -4. And the good news is it doesn't matter which way you go. I could have gone down 5 and right 4, and I still would have had a fraction with a negative sign in it. So we're going to type this into our answer box here at the bottom. Y equals -5, division sign 4, and then the fraction will appear. Arrow out to get the x on the side, and the -7 at the end. Again, one more time. Find your y-intercept number first, and put it here. For us, it's a -1. Find your change in y, and your change in x should be the same every time from corner point to corner point. So it looks like we have a change in y of down 1 and right 2. You can use a fraction or a decimal when you're typing here. Y equals -1/2 x minus 1, or you could have put a 0.5. Last one. The y-intercept is -2. The change in y is 1, 2, 3. The change in x is 2. Our line is definitely increasing or going uphill, so our slope should have 2 positives. Y equals 3/2 x minus 2. And that concludes homework 17.